Hello, students, and welcome to our new chapter, Two-Dimensional Motion and Vectors. And today I just want to introduce vectors. You might say, what is a vector? Well, in physics and science in general, quantities could either be considered scalars or vectors. And I'll let you go ahead. You can always see these notes in either Google Classroom or right up here. You could pause this screen. Some vocab here. And just real briefly, the scalar could be considered something like length or volume. Vector, though, always has a direction. So, like your displacement has a direction. Your velocity has direction. And what you could do is pause this here, maybe take some notes. But I gave some examples of scalar quantities and vector quantities along with the units for each. Like I said, volume, 5 cubic meters. That's a magnitude, it's a size. If you're counting something, you can count that. It's a volume, it's a size. The main vectors we're going to focus on early here are displacement, velocity, and acceleration. And notice here I included the quantity with its units and also the direction when I'm talking about vectors. So velocity, 8 meters per second northward. Acceleration, say you're dropping an object, 9.8 meters per second squared toward the Earth's surface. It's directed downward. It's things like that. And there was if you're going to see me type it out, I'll always make a vector bold. If I'm going to write it out, I'm going to put an arrow on top. And I was able to type it here in this case, but just that also is how you can write vectors to me, by putting that arrow on top. Now, in this case, say you had a gecko and it crawled up 60 centimeters, and then it climbed down 30 centimeters. What's the gecko's total displacement? We could think of that in terms of the resultant vector as being a combination of two single vectors. So like it went up 60, and you're going to have to forgive me for how bad that looks. It went up 60 and it went down 30. So you could think of that, the resultant vector is the gecko ended up 30 centimeters up that tree, which, if we're doing the math, that's how that works. Second example, he walked 3 meters east, then he walked 4 more meters east. What is the total displacement? Again, you could think of that as combining two vectors. He went 3 meters east, then he went 4 more meters east. And if you had a ruler, you could literally say, this is not drawn to scale, but you could literally say that he went the whole 7 meters east, and see how there's a direction. Now we'll use arrows a lot in this class. To finish things up, this is what your homework will be. There's a little exit ticket. Let me know if you have questions, and good luck and have a good time.